Imagine a time when a simple sore throat could be a death sentence for a child. In the late 19th century, a terrifying shadow loomed over every nursery in Europe. This shadow was known as the Strangling Angel, a name given to the disease we now call diphtheria. It earned this fearsome nickname because of the way it claimed its victims, creating a thick, gray membrane in the throat that slowly made breathing impossible. For parents of that era, there was no greater fear than seeing that gray patch appear in their child's mouth, knowing that medicine was largely helpless to stop it. At the time, hospitals were places of resignation rather than recovery when it came to infectious diseases. But inside the laboratories of Berlin, a small group of scientists was working with a feverish intensity to change that reality forever. They were not just looking for a way to understand the disease, they were hunting for a weapon that could finally strike back. At the heart of this struggle were Emil von Behring and his colleague Shibasaburo Kitasato. They worked under the watchful eye of the legendary Robert Koch, a man who had already revolutionized medicine by proving that specific germs cause specific diseases. The atmosphere in Koch's laboratory was electric with discovery. The scientific world had only recently accepted that microscopic organisms were the culprits behind humanity's greatest plagues. Now that they knew the enemy, the next logical step was to find a way to fight it. But diphtheria presented a unique and baffling challenge. It didn't behave like other bacteria that simply invaded the body and multiplied until the system collapsed. Diphtheria was more sophisticated and much more lethal. The bacteria responsible for this suffering, Corynebacterium diphtheriae, was particularly insidious. Behring and Kitasato realized that the germ itself stayed mostly in the throat, yet its effects were felt throughout the entire body. It was as if the bacteria were launching a long-range attack. They began to understand that the bacterium was producing a potent toxin, a deadly poison that traveled through the bloodstream. This toxin was the real killer. It caused the formation of that horrible gray false membrane, but it also traveled to the heart and the nerves, causing damage far from the site of the initial infection. To help people understand this, the scientists thought of the bacterium as a small pirate on a ship. Instead of attacking with swords in a direct fight, this pirate would stay anchored in the throat and launch toxic smoke bombs. These bombs would drift across the body, immobilizing vital functions and damaging the heart even though the pirate himself hadn't moved. This realization changed everything for Behring and Kitasato. They stopped looking for a way to just kill the bacterium and started focusing on the poison it produced. Their hypothesis was radical for the time and challenged the conventional wisdom of medicine. They believed that if an animal could survive a diphtheria infection, it must be because its body had developed a way to neutralize that specific poison. This was a shift in thinking from the idea of a magic bullet that kills a germ to the idea of a natural defense that disarms a weapon. They suspected that the blood of an animal that had recovered or been made resistant to the disease would contain secret antidotes. It was a beautiful and revolutionary concept. The cure was not a chemical found in a jar, but a defense mechanism found within life itself. The road to proving this theory was long and required immense patience. They began their experiments with small animals like guinea pigs and rabbits. The first step was to see if they could teach the body to recognize the danger without killing the subject. They injected these animals with small doses of weakened or inactivated diphtheria toxin. It was essentially like showing the body a photograph of the enemy's weapon so the immune system would know what to look for, but without the toxin being strong enough to cause actual damage. This was the birth of what we now call active immunity. The results were encouraging. The animals didn't die, instead, they became resistant. When these same animals were later injected with a full, lethal dose of the toxin, they survived. Their bodies had learned how to defend themselves. However, the real breakthrough, the moment that would change the course of medical history, happened when they took a blood sample from these immune animals. They separated the blood to get the serum, which is the clear liquid part that doesn't contain cells. They then took a sick animal, one that was on the verge of death from a diphtheria infection, and injected it with the serum from a resistant animal. The results were nothing short of miraculous. The dying animal began to recover. It was as if the serum contained tiny, invisible soldiers or shields that rushed through the bloodstream to intercept and deactivate the toxic smoke bombs. Behring called these protective substances antitoxins. This process, which they called passive immunity, was essentially a loan of defenses. One animal could share its strength with another to provide an immediate shield against death. When this discovery was published in December 1890, it hit the medical community like an earthquake. For the first time, science had proven that the body could produce a specific substance to fight a specific poison, and even more importantly, that this protection could be transferred. It was no longer a theory, it was a promise that medicine could actively reverse the course of a deadly disease. But a discovery in a lab is very different from a treatment that can save thousands of people. The next phase of the journey was perhaps even more difficult than the first. They needed to move from small test tubes to a scale that could treat the children of Europe. This required a massive leap in production, and for that, Behring turned to an unlikely source, the horse. Horses were chosen because they are large, healthy animals that could produce vast quantities of serum. By immunizing horses, the scientists could turn them into living factories for the antitoxin. But the logistics of this were monumental. They had to keep the horses in peak health, carefully manage the immunization process, safely extract the blood, and then process that blood into a pure serum. This is where another brilliant mind entered the story. Paul Ehrlich, a master of immunology, joined Behring to refine the process. Ehrlich realized that for the serum to be a real medical tool, it had to be standardized. They couldn't just guess how much antitoxin was in a dose. Ehrlich developed meticulous methods to measure the potency of each batch, ensuring that every injection had the right number of antitoxin soldiers to do the job. Without his precision, the serum might have been inconsistent or even dangerous. The tension reached its peak on Christmas of 1891 in a hospital in Berlin. This was the first time the serum would be tested on a human child who was dying of diphtheria. You can almost feel the heavy silence in that hospital ward. Parents were clinging to every ragged breath of their children, caught between the despair of the disease and the flickering hope of this new, untested treatment. Behring administered the serum to a child in the final stages of the illness. It wasn't an overnight miracle for everyone, and the doctors had to work hard to refine the dosages and the timing of the injections. But soon, the data began to speak for itself. The children who received the serum started to get better. They began to breathe again. The gray membrane cleared, and the strangling angel was forced to let go. As the use of the serum spread, the impact was nothing short of monumental. In just a few years, the statistics of death were rewritten. Before the serum, the mortality rate for children with diphtheria was a terrifying 50% or higher. In some outbreaks, it was even worse. But with the introduction of the antitoxin, those numbers plummeted to less than 10%. In some areas, the death rate even dropped below 5%. Thousands upon thousands of lives were being saved in every city where the serum was available. This was the first time in history that an effective treatment had been developed for a major infectious disease. It transformed the role of the doctor from a helpless observer who could only offer comfort into an active intervener who could offer a cure. The world took notice of this triumph over death. In 1901, the very first Nobel Prize in Physiology or Medicine was awarded to Emil von Behring. The committee recognized his work on serum therapy, specifically its application against diphtheria, noting that he had opened a new path in medical science and placed a victorious weapon in the hands of physicians. While Kitasato and Ehrlich were not named in the prize that year, their contributions are now recognized as essential to the success of the project. They were the architects of a revolution that changed how we perceive the human body and its ability to heal. Behring's work showed that the solution to our greatest threats wasn't always found in destruction, but in understanding and empowering the body's own innate wisdom. The legacy of the diphtheria serum extends far beyond the lives it saved a century ago. It was the catalyst for the entire field of modern immunology. Every time we use a vaccine to protect a child, we are using the principles of active immunization that Behring and his team explored in those early lab experiments. When we see modern treatments for cancer or autoimmune diseases that use the body's own immune system to fight back, we are seeing the evolution of the path Behring first cleared. He taught us that the blood is not just a fluid that keeps us alive, but a complex battlefield where we can intervene to tip the scales in favor of health. The shadow of his work covers almost every aspect of how we fight infectious diseases today. The story of Emil von Behring and the serum that saved a generation is a powerful reminder of what is possible when human ingenuity meets profound empathy. It was a battle won against a relentless and invisible enemy that had claimed the lives of millions of children throughout history. It proves that behind every great medical breakthrough, there is a story of challenge, of courage to think differently, and of an indomitable will to reduce suffering. The victory over the strangling angel showed us that hope, when powered by science, can transform a future of despair into one of health and life. We live in a safer world today because of the feverish work done in a Berlin laboratory over 100 years ago, a legacy that continues to protect generations yet to come. If you found this story of medical history inspiring, please subscribe to the channel for more deep dives into the discoveries that changed our world. For more information, visit minrora.com.